Hi there, and welcome to this video from the algebra section. This is going to be the first of two videos where we're going to have a look at number sequences. And you might be thinking, why is number sequences part of the algebra section? Well, you'll see we're going to describe sequences later on using some algebra, so that's why it's part of the algebra. So here we go. Let's start off first of all by just creating a sequence of numbers just using a pattern. So here we go. So here comes our pattern. We've got a whole bunch of squares. So there's shape number one. Shape number two is this kind of T shape, and each time this T shape is getting a bit bigger. And so how many squares will we need for shape 5? So let's have a look at how many of these individual orange squares we need for each of the shapes. So shape number 1 just needs the 1 square. Shape number 2 needs 4. Shape 3, you can see we've got 7 squares there. And shape number 4, we've got 10. So you can see we're generating a sequence of numbers, and hopefully you've spotted that the pattern goes up in 3s each time. So the question says, how many squares will we need for shape 5? We're going to need another 3. So in total, we're going to need 13 squares. Okay. Here's a question. If we had 25 of these orange squares, 25 of these little squares, what's the biggest shape number I could make? Well, clearly 10 of them would be used to shape 4, but if I had 25, what's the biggest shape we could come up with? Now, I'm not going to spend my time drawing this out. What I'm going to do is try to figure it out from the number pattern that we've got here. So what I'm going to do is think about, we said shape 5 has got 13 squares. So the one after this one has got 13 squares, and I've got 25 squares to use. So what that means is I've got an extra 12 squares to build on from shape 5 upwards. And we need to think about kind of how is it building? Well, we said earlier the pattern goes up in 3s. Why is that happening? Well, let's just have a look. Well, it's because each extra shape needs 3 extra squares, and there they are. They're kind of the ones on the ends of the top bit and one on the stick going down. So basically, what we're saying is if I need 3 extra squares for each new shape, and I've got 12 extra squares to build with, that means I can do that process of putting on the extra squares. I can do that process 4 times. So if I know shape number 5 required 13 squares, I'm going to do that 4 times. So that means shape number 9 is going to be the one I can build from 25 squares. So there we go. Now, so you can do it by drawing them out, but with sequences it's much quicker, much easier just to kind of have a look at the pattern of the numbers and figure it out from there. Okay, so that was just an example where we're using a shape pattern to create a sequence of numbers. I mentioned earlier that we can do this algebraically, so let's have a look at how we can use algebra to create a sequence. So here we go, here's a question. It says, what sequence of numbers is made from the rule 4n minus 1? Now that might look a little bit weird to begin with, but what we're going to do is explain what's going on with this n bit here and how this thing is going to be used to generate a sequence of numbers. So what I'm going to do is start off and say, okay, well, in our rule here, let's make n, that thing there, be worth 1. So 4n minus 1 becomes 4 times 1 minus 1. So the n, this thing here, is worth 1. So the first number that I can make using that rule is going to be a 3. 4 times 1 take away 1. To get the second number in the sequence, what I'm going to do now is say, okay, well, let's make n be worth 2. And so this is now worth 2. So we've got 4 times 2 minus 1. And so that gives me 7. Now let's make n worth 3. So we've got 4 times 3 minus 1, so that's 12 minus 1, which is 11. N is now 4, so I've said kind of this is n equals 4 is the maths way of saying, okay, let's make n be worth 4. And so I've got 4 times 4 minus 1, which is 15. And so on, and so on, and so on. So you can see now how that rule, just by changing what n is worth, and by making it get bigger by 1 each time, we can generate a sequence of numbers. And there's our numbers 3, 7, 11, 15. And so on from there. So what we've got is a sequence of numbers that goes up in 4s. And we could keep going, keep going, keep going, and let's say that sequence would keep going on forever like that. Now, here's a question for you to think about. Just looking at that, why is it, do you think, that this number sequence goes up in 4 each time? What is it within the rule that means it's going up in 4? And I'll leave you to have a think about the answer to that question yourself. Okay, on we go. Let's have a go at another one. So this one's a slightly different looking sequence, exactly the same principles, we want the first 5 terms of the sequence that's described by this rule here, n bracket n plus 4. So exactly the same principle. We're going to start off, we're going to make n be worth 1, so n is 1, and so my rule becomes that. So I'm just going to put the number in, same as we've done previously in our work with algebra and substituting in numbers. So I've got 1 times by 1 plus 4, and again a bit of BODMAS says we've got to work out that bit first, so that becomes 1 times 5. So the first number for this sequence is a 5. Now let's make n be worth 2. So we've got 2 times 2 plus 4, 2 times 6, which is 12. N is now worth 3. So 3 times 3 plus 4, so that's 3 times 7, which is 21. And on we go, n is worth 4. And I'm going to do these quite quickly, but I'm hoping now that you're getting the idea of what's going on. So 4 times by 4 plus 4, so that's 4 times 8, which is 32. And now for the last one, we want when n is worth 5, because the question is asking us for the first 5 terms of the sequence. When n is worth 5, plug in the number 5 instead of n, as we've done before. That gives us 5 times 9, and so the fifth term is 45. Sorted. So there's our sequence of numbers, and then like a little bit more complicated, but exactly the same principle. What the key to it is working out that, you know, we've just got to keep changing the value of n each time, and it will generate our sequence. So a final question to do with the sequence, and the question is what would be the 10th number in this sequence? Now, one way of doing it would be to look at these numbers and try and figure it out, and then just kind of keep going to work out n is 6, n is 7, n is 8, but we really don't need to do that. By far the simplest thing to do is just say, well, you know what, for the 10th number, n is going to be worth 10. So all I've got to do is say, well, if n is 10, plug it into my rule. So I've got 10 times 10 plus 4, so that's 10 times 14, which is 140. So there we go. The 10th number in this sequence would be 140. And then the one thing that is well worth having a look at, the temptation here would say, well, if I know the 5th term is 45, you find a lot of students will try and just kind of double that and say, okay, the 10th term is going to be 90. But it's absolutely not. It doesn't kind of work that way. So what we're saying here is that the 10th term is not double the 5th number. So what we needed to do was just plug in n equals 10 into our formula, and there we go. We've got our answer.